Hey everybody, thanks for tuning in. We are the Professor's DuBois, and in this video, we're going to talk about the periodic table.
Periodic table. It's really important. You ready to get started?
Let's get started.
Okay, let's do it. All right, periodic table. Periodic table is a collection of all of the elements that we have either discovered or actually produced in the laboratory, and it is divided into either rows or columns, and our rows are called periods from left to right, and the columns are called groups or families. And the reason that they are called families is that they have very similar characteristics, just like families might have something in common, like red hair or musical ability. These elements will behave very similarly when they have chemical reactions. We call these groups or families. The periods are from, just top to bottom, 1 through 7. The groups are either 1 through 18, or is listed the way that we're seeing right now, is they're broken into A and B. So these 8 A groups are the main group elements, and the B is they're called the transition metals.
A lot of times on my own personal periodic table, I'll write the period number on both sides so I don't get confused. Because if you're working on the right-hand side, sometimes it can be a little bit tricky. So I actually label mine.
Good tip.
It's a pro tip.
It's a pro tip.
So this is the periodic table just kind of laid out as whether the elements exist as metals or nonmetals. And there's even another category called metalloids. Now, metalloids are kind of strange because they kind of have properties of both. They can behave like a metal and a nonmetal. So we call these metalloids, and you can see they're kind of like a diagonal staircase. They're colored green in this image. These are the metalloids. And also notice that most elements are metals. And we've even subdivided the metals into the main group. Remember from the previous slide, the A's, 1 and 2A, and then we could go over to 3A or 13. And then the transition metals, which is just a nice, clean, square brick right in the kind of the center of the periodic table. These are called the transition metals.
And when he talked about the metalloids behaving like a metal or a nonmetal, metals tend to lose electrons, and the nonmetals will gain electrons when they react. So the metalloids can do both. These are some names that you really should be familiar with from your periodic table. So these groups often have common names. So the first group are collectively called the alkali metals. The second group, the alkaline earth. And then we talked about these transition metals. These are the B group elements. Moving down, these are called the inner transition metals, or the lanthanide and the actinide series. The next set is pretty obvious, so the boron family, the carbon family, nitrogen, oxygen. Then we have a common name again. The halogens are the group 17 or 7A elements, and then the last column is the noble gases.
Now, notice that hydrogen isn't colored as the alkali metal, but it's in that group.
That's a good point. So hydrogen is considered a nonmetal. So we can actually move hydrogen a little bit over here. Sometimes you'll see hydrogen listed over here because it really is, it behaves as a nonmetal mostly.
But it does have properties consistent with the alkali metals in group 1.
Yeah. A common question you might see is, okay, what is the halogen in group 4? So you'd need to know that...
Wait. Period 4.
Period 4. Good catch. In period 4. So the halogens are in group 17, and you'd have to go down 4 periods, 1, 2, 3, 4, and go across to your halogens, and you'd find that that was bromine.
Br. Now, there are 7 elements that exist as diatomics, and what we mean by that is if we had pure... let's just talk about hydrogen because it's one of these. If we had a sample of pure hydrogen, these hydrogens would be covalently bonded, and there'd be 2 of them. So they would pair up. You wouldn't find individual hydrogen atoms. And there's 7 of these. And if you kind of look at the periodic table, they kind of form the number 7, which can be a good help in remembering which ones these are. with the exception of hydrogen again. That's a real troublemaker, isn't it? So these are diatomic elements when we write. So if you wanted to write the symbol for just say a metal like iron, you would just write Fe. Now if you were going to write nitrogen, it would be correct to write N2 because that's a diatomic and that's how that will exist.
Yep, so that would be nitrogen gas. All right. It's kind of easier to just learn these, kind of memorize these as you go forward. It'll save some time in some exams. You should know what the state of the elements are at room temperature. The gases are the noble gases. Those are the group 18 elements, as well as hydrogen, nitrogen, oxygen, fluorine, and chlorine. The liquids at room temperature, there are only two. One is a metal, mercury. We know that mercury is a liquid. And bromine is the other liquid at room temperature. Everything else is a solid. And the diatomic elements, you can memorize them. There's a couple different mnemonics, Brinkelhoff, Hoff-Brinkel. We learned it as have no fear of ice cold beer. Never forgot it.
I'll never forget that.
Never forgot it.
Some periodic tables will even kind of color code the elements as to what state of matter they're in. So
That's helpful.
The liquids will be blue and the gases will be red. And so you can find them quickly that way as well.
Yep. And you can color code your own periodic table as well.
Eletropes are when we have an element that it's just a pure element, but due to the bonding arrangement, it might have totally different properties. And my favorite example, because it's easy and I want to make this easy, is carbon. So carbon can form bonds and form graphite, like in your pencil. That's pure carbon. Well, carbon also is what makes up diamond, which is very, very different than pencil lead. And we call these allotropes, and it comes back to bonding arrangements. And we're going to get into bonding arrangements further along in the semester.
Another allotrope, if I go back to this, is oxygen. Oxygen can exist as O2 or O3. These are allotropes of each other, and they have very different properties. One sustains life, one takes it away. So this is ozone, O3. You don't want to breathe that. So we want to give you some examples of what you might need to use your periodic table for, some questions that you might have to answer. So go ahead and pause the video, take a shot at these questions, looking at your periodic table, and we'll give you the answers in a moment. Here's your answers.
Okay, thanks everyone for tuning in. We really appreciate it, and we hope that we found that useful. Stay tuned, because coming up next, we're going to get into covalent compounds and naming covalent compounds. And this is where, chemistry starts to get really, really fun.
Thanks for tuning in. Bye-bye.